Welcome back to Caroline's Chemistry. Today we're tackling one of the most confusing topics for A-level students, back titrations. In this video we'll unpack exactly how back titrations work, why we use them, and how to approach the calculations with a calm, methodical process. I'll show you how to spot them in exam questions, how to set up the equations, and how to avoid the classic trap of forgetting which substance you're actually calculating for. By the end, you'll be able to handle any back titration question confidently, tracing your way from start to finish. Let's dive in.
Let's start off with what a back titration is. And in order to do that, I think a reminder of a titration is a good idea. So a titration is an experiment that is really accurate, and it's done in order to find the concentration of an acid or an alkali. If you feel a bit rusty on titrations, then I highly recommend that you go back to the titration video that I did. It's in this playlist before you then go on to look at back titrations. A back titration, we would use it when we are trying to analyze a base of an acid that does not react easily or quickly. So an example might be a base that is a bit insoluble. So it's kind of dissolving slowly, and it means when you add acid into it, it's really hard to get that very distinct color change that happens with one drop that you need for a titration. So if that is the case and you have a base of an acid that doesn't react easily or quickly, what we do is we take that base or acid and we treat it with an excess of the acid or base. And because you've used an excess, it means you're going to have amount that's reacted and then amount that is left over. And what we do is we then take that leftover amount and we titrate that. Then we work backwards to find out about the original base or acid, hence the name back titration. The first thing that we are going to do for any back titration is to work out what is reacting with what and in which order. So we have two chemical reactions going on here. The first one, we take copper carbonate and an excess of HCl is added. So that's the first chemical reaction that's happening. Before I move on, I'm going to check the reacting ratio now. So copper carbonate, the carbonate ion is what's reacting, it's CO3 2-. That reacts with 2 H+ ions. Now that we have the first reaction, we can see that the leftover HCl was then titrated against sodium hydroxide. So that's the second chemical reaction that occurred. That is a 1-to-1 ratio because hydrochloric acid is monoprotic, it releases 1 hydrogen ion, and sodium hydroxide is monobasic, it releases 1 hydroxide ion. Now we are super clear on the two chemical reactions that occurred. We're going to follow the clue that's in the name. It's a back titration. We're going to start at the end with the sodium hydroxide. Now we're given some information about that. We're told that the moles of sodium hydroxide that was required is 0.15. Now let's work backwards to the HCl. Now this hydrochloric acid is what was left over, it's what didn't react up here. So leftover moles of HCl is 0.15, also because it's a 1-to-1 ratio. Now don't forget a crucial question at this point, in what volume? We're told that 25 centimetre cube portions of the solutions was titrated. So that is 0.15 moles in 25 centimetres cubed. However, the actual solution that we started with, the stock solution, was 250 centimetres cubed. So the leftover moles of HCl in 250 centimetres cubed is therefore 1.50. So that's what's left over. We also know the start moles of the HCl. We're told it in the question, 5.00. So now we can start to work out, well, how much actually reacted here? I know how much was left over. I know how much I started with. So reacting HCl is therefore what I had at the start minus what reacted, which is 3.50 moles. Final step is to then work back to the copper carbonate. So this is a 2-to-1 ratio. Now I know how much hydrochloric acid reacted. I can work out the moles of CuCO3 by dividing by 2. So 3.50 divided by 2 gives us our overall answer of 1.75 moles. Let's start with those two reactions. So reaction 1, calcium carbonate, is reacting with HCl. Reacting ratio. Carbonate ion reacts with the hydrogen ion in a ratio of 1:2. Second reaction that happens is the leftover hydrochloric acid was titrated against sodium hydroxide, and that's a 1:1 ratio. So, clues in the name, back titration, was starting at the back and working back towards that first equation. So the moles of sodium hydroxide, we're now going to calculate because we're given the volume and the concentration. So N equals VC, moles is equal to volume times concentration. So 24.8, that's my volume. I'm dividing it by 1,000 to turn it into decimeters cubed and then timesing by 0.1 the concentration. That gives me 2.48 times by 10 to the minus 3. Now I have the moles of sodium hydroxide. I can work to the moles of HCl that was left over. So we have moles of HCl left over, i.e. didn't react with the calcium carbonate. That's a 1:1 ratio and it's 2.48 times 10 to the minus 3. Now I have to ask myself that very important question, in what volume? So we don't have a stock solution. It's saying here the entirety of the excess acid was titrated in this next reaction. So I don't have to adjust for anything here. It wasn't that a small sample was taken out of the stock solution. That is the total amount that was left over. Now let's work out, therefore, how much we had to start. So we're told that we had 100 centimeters cubed. Divide that by 1,000 to turn it into decimeters cubed, and times it by the concentration. So I have 0.02 moles to start off with. The reacting moles of HCl comes next. So we take how much we had to start, we minus how much reacted with the sodium hydroxide, and that gives us 0.01752. So we're now up here. We know how much actually reacted with the calcium carbonate. To work out now the moles of the calcium carbonate, it's a 2:1 ratio. So I'm going to take my moles of the hydrochloric acid that reacted and divide it by 2. So 0.01752 over 2 gives us 8.76 times 10 to the minus 3. We're nearly there at this point. This is the moles of the calcium carbonate. But we're asked to calculate the percentage of calcium carbonate in the limestone. So I first now need to turn this into a mass. So mass of calcium carbonate, mass is equal to Mr. moles. So the MR of the calcium, we can work that out from the periodic table. 1 calcium, 1 carbon plus 3 oxygens is 100.1. Times that by the moles, 8.76 times 10 to the minus 3. And we get a mass of 0.876876. I'm going to keep that whole number because it's still not my final answer. To find out now the percentage of calcium carbonate, I'm going to take the mass of the calcium carbonate that we've just worked out, divide it by the mass of the limestone, and times it by 100. There we get 87.7%. And giving that to 3 significant figures, because all of the data that we ended up using in the question was 3 significant figures as well. So these are the mistakes to watch out for when you are doing back titration calculations. It is a multi-step calculation. There's lots of places to lose your way and get confused. And this is why I say, don't start your calculation with numbers. Start each line with words explaining what the numbers mean, because it gives you a better roadmap and understanding of exactly what it is that you are doing here. You are not just slotting numbers in at random, spewing them out and hoping for the best. So that means start your calculation with moles of HCl, moles of NaOH, etc. Then ask yourself that really important question, in what volume? I have calculated a number of moles. In what volume? Because quite often in titrations, you have a stock solution and that can be quite a lot of volume. So like say a litre or 250 centimetres cubed of stock solution. But that's too much to do a titration with. So quite often we take a small amount out of that stock solution and just titrate that small amount. So it means often you need to take that into account. If you've taken out 25 centimetres cubed, you'll need to times by 10 up to find the moles in the whole stock solution. So always ask yourself, in what volume, so that you can work out what does this number of moles mean? Do I need to be taking into account this stock solution idea? The next one, kind of mentioned it, but just to highlight it again, don't guess and start throwing numbers around. Always start back titration, and if it helps anything, like work out what is reacting with what. Write those 2 equations to begin with in order to figure out your roadmap and figure out your reacting ratios first, because if you're doing it whilst you're in the thick of things, it's easy to lose. Is it a 1:2, a 2:1, a 1:1 ratio, etc. So use those 2 equations mapped out to give yourself that roadmap and to not miss a reacting ratio.
Thanks for watching, and if you found this helpful, then hit like and subscribe now so that you can get new weekly chemistry videos for your GCSE or A level so that you can do the best you can do.